Polar coordinates. Tell me, what's 3 and what's pi over 2 if this is a polar coordinate? What do we list them off as? Tell your neighbors. What is it? It's an r. It's a theta. R would be considered a distance from the origin or a radius. Distance from the origin I won't write. Or theta is an angle. We remember, especially if we played Battleship, that you will go to an angle location and you will go a distance away from the origin, typically in that direction. So I would go to the angle of pi over 2 and I would go 3 towards pi over 2. Now, if you remember from Battleship, sometimes, and you'll see this maybe on your homework, maybe not today, but next class, that there are these concentric circles which show you like being 1 away versus 2 away versus 3 away. Like, don't draw those. We are just like ballparking it. Really, we just care about the quadrant or the axis, and like 3 is going to be further away than 2, which is further away than 1. Cool? All right. So let's graph a couple more. Ready, set, go. Go B, C, D, and then we'll talk about E. Now, I don't want X, Y's. I want you to graph the point like on axis. I don't want the X, Y's. I want you to just approximate the location like I just did here. We're like making sure we're doing our homework correctly. This is the location 3 comma pi over 2. Okay, so graph 1 pi. Okay, we will go to the r of 1. We go to the theta of pi. Where is 1 pi? This is what I want you to do. I do not want you to transfer it to x's and y's. We'll do that on the next page. We go to the angle of pi. We go 1 away. So it's like somewhere over there. 2, 5, pi over 4, 1/2, 4 pi over 3. Go ahead and do those. Don't change them to x, y's. We'll do that on the next page. We're just keeping it simple here. Make sure you're in the correct quadrant. Great. Five pi over 4 is in the third quadrant. 2 there. If you gave me the x, y's, great. That's fine. Don't need them. We'll do that next page. Here, 4 pi over 3, 1/2. 4 pi over 3 is the 60-degree reference angle in the third quadrant. 1/2 will be very close. Cool. Now we get to E and F, and they're trickier. First, let's talk about what happens if our radius is negative. Everybody, tell your neighbors, what happens if your R is negative? Yeah, it ends up going in the opposite direction as your terminal ray. So if you have the angle pi over 6, your angle pi over 6 is the 30-degree reference angle in the first quadrant. You're going to go in the opposite direction. So here's pi over 6. Maybe you can draw it if you wanted to. But you will go in the opposite direction towards 7 pi over 6, 2 units away. Cool? Now, if you're already working ahead and you did F and you did the following, pi over 3, 3, and you're here in the first quadrant, I'm sorry, you were wrong. Because you can't flip-flop thetas and r's. This is still an r. This is still a theta. Tell your neighbors, what quadrant, approximately where, is pi over 3, 3, if that's an r, then a theta? I'd be a little bit more exaggerated, but I like what you're doing. Yeah. Yeah, I tricked you. What do you think, Hall? Yep. There you go. So the theta of 3 is very close to the theta of pi. We've been doing this more often recently, trying to trick you with like whole numbers as radians as ratios sometimes. And I'm going to be very exaggerated. I'm pretty sure 3 has got to be 170 something degrees. Oh, I'm so exaggerated that it wanted to be a straight line. We want to be really close to pi. Huh. Well, you know what I'm trying to do here. Very hard to draw straight lines, which is why I have the straight line tool. The straight line tool turns anything into a straight line, turns circles into circles, triangles into triangles. Very helpful while teaching. Pi over 3 is very close to 1. Like pi 3.14 divided by 3 is approximately 1. This is approximately pi. So we're probably somewhere in the second quadrant, very close to pi 1, or 1 pi is what I meant to say. We get there. Cool. Now, the next thing we learned last class that we're reviewing right now, and we're kind of working through our homework while we're doing this, is how the points R2, theta 7 pi over 4, which is right around there, can be expressed an infinite amount of ways. The whole idea of going around our circle comes into play, and we can end up in the same location. But now we have other options with the idea of having negative radiuses or negative distances. If you remember from last class, I challenged you, and I'm going to do the same thing. I would like you to provide 3 different polar coordinates with the following constraints. The first one, I'd like to have a negative radius and a positive angle. The next one, I'd like to have a negative angle and a positive radius. And the third one, I'd like to have a negative angle and a negative radius. And I'd like you to be able to adjust and adapt. It helps if you just like are comfortable with going in both directions, either positive around your circle or negative around your circle. Don't forget about directions of adding and subtracting angles. And then don't forget, like, you got to be halfway around your circle to go in the opposite direction. So go ahead and try to give me 3 like co-located points. And I'll call on people randomly to make sure you guys are paying attention and are figuring this stuff out. Good first one, Winston. Nice. 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 You're already ahead of the game?
Yeah. We had a bit, and I was like halfway through.
Oh, okay, so you just do it again? All right, cool. Grab another homework and like do it again while we're doing it. All right, Jolly, give me one. Beautiful. McCorkle, give me another one. Beautiful, easy. Okay, give me another one. Yeah. Okay, give me another one. Perfect. Okay. Repeat. You know, no big deal. If we're comfortable, positive, negative, going around the circle, going halfway around the circle, this is no big deal. So let's move on. New stuff. Okay, go to your notes. It's not really new. this extra page of notes is where we kind of left off last class. Okay. Converting rectangular coordinates into polar coordinates, converting polar coordinates into rectangular coordinates. There are some like formula that you could use, but I find it's easier instead of using r cosine theta and being like, oh, I'm just going to memorize x is r cos theta and y is r sine theta, and you can like reverse things by using like tangents and going from a theta to a y over x, like stuff like that. Instead of doing that, it's good to remember, but I'm not going to underline. Instead, I'm just going to remember from Unit 6, our friends, the 30, 60, 90 triangle, the 45, 45, 90 triangle. We remember that trigonometry essentially is just scaling of similar triangles that we know, where you can use a multiplier to make larger 45, 45, 90 triangles. And for 30, 60, 90 triangles, you remember a short side, a long side. You could also use a multiplier to get larger 30, 60, 90 triangles, because trigonometry is really just like the ratios in these right triangles must be consistent. The sine of 60 degrees, no matter where the 60-degree angle is, if it's in a right triangle, the sine of 60 is root 3 over 2. The cosine of 60 is 1/2, no matter what triangle you look at. So what we do is maybe this approach, maybe you like this approach. You realize that if you have an x coordinate of 5, you're going to the right 5. If you have a y coordinate of 5 root 3 that's negative, you're going to be going down more than you went over. And you're thinking, oh yeah, that just creates a triangle. So it's almost like I don't even plot the point. I go straight to, oh, that's a triangle with an x distance and a y distance. And then you realize, oh, this is a triangle that I'm familiar with. This is a triangle that has a 60-degree reference angle. That is this 30, 60, 90 triangle that is scaled. You figure out what your multiplier is. You can set up an equation to solve. M times 1/2 is 5. Or you just be like, oh, this has to be 10. If you wanted to, you see that the adjacent side is 5. You go m times 1/2 equals 5. M has to equal 10. Oh, if m's 10, that's 10. Bam, that's your radius. What's your angle? Well, you know it creates a tall 30, 60, 90 triangle. We're in the 4th quadrant. Write down the angle. Already done it? Yeah? Yeah? What did you get, Lazara? You're just nodding your head, being like, yep, I got it. Then I just ask you, what did you get? And you're like, what? The top left one on the notes, Lazara. The angle, bud. Man.
Oh,
Glad I called you. Great. You know what? I like that answer. Many of you are like, oh, what about 5 pi over 3? Sure. You can put that one too. That's okay too. Like, it doesn't have to be from 0 to 2 pi. We need to be more comfortable with negative angles. We need to be more comfortable with going in different directions. We're good. Okay. The next two involve our 45, 45, 90 triangle, and I just want to show you it quickly. I have an x of -8 and a y of 8. I'm going to create a triangle, and I know since the x and the y have the same length, essentially, that we have a 45, 45, 90 isosceles triangle for this one, The angle is probably easier to figure out. Maybe you're going to put 3 pi over 4 right off the bat. Some people have difficulty finding the radius. You could always use the Pythagorean theorem, or we can convert this 45, 45, 90 triangle so that this is M, this is M, or this is 1 times M, this is 1 times N, and this is some ratio times M. And the way we do that is by either multiplying by root 2 or multiplying by 2 over root 2, dividing everything by 2 over root 2. If you multiply this by root 2, if you multiply this by root 2, and if you multiply this by root 2, you realize that root 2 over 2 times root 2, it's the same as dividing by 2 over root 2. You get this new scaling where, sorry, this goes away. If this is M, this is M, this has to be root 2M. And this is actually what's usually taught in geometry classes. Usually taught that for 45, 45, 90 triangles. If you remember, when you first learned these special right triangles that Miss Pate, anybody have Miss Pate here? Yeah, Miss Pate taught you this is X, this is X, this is root 2X. That's how geometry teaches. You get to pre-calculus, and we then go, well, oh, I didn't click the right button. You get to pre-calculus, we then change it to this is 1, this is root 2 over 2, this is root 2 over 2, and then there's where your x's land. So anyways, regardless, if you have whole numbers, the radius is 8 root 2, the number root 2. All right. This is kind of the version we're used to seeing, so go ahead and figure this one out. You have 4 root 2, negative 4 root 2. What is the radius? What is the angle? Then we'll go to the last one, then we'll move on. And then we'll get to different stuff that none of you are familiar with, which will lead us to some introductions to some very complex things. Hopefully, you'll be paying attention because it's very interesting for those of you who consider yourselves math students who like to learn new things. Not all of you are those people. Some of you are. But we'll see when we get there. Perfect. I go right and down. I am in the 4th quadrant. You can put 7 pi over 4 or negative pi over 4. I don't care. You're ready for both. You see the side lengths are equivalent, which is why you have a 45, 45, 90 isosceles right triangle. I'm probably using negative pi over 4. I'm glad you guys are using it too. It means you're kind of like remembering inverse trig, because inverse trig loved using these negative angles. And if you think about your 45, 45, 90 triangle, if you want to set up an equation, root 2 over 2 times m, root 2 over 2 times m equals 4 root 2, m has to equal 8. Then we get to the last one, and sometimes the last one is the trickiest one. It's an x and a y coordinate. It's not a triangle. It's an x and a y coordinate, which you turn into an r and a theta. So please do this last one so that I know what you know what you're doing. And then you can get to your homework and you'll be able to crush A, B, C, D, and F of the next 3. Great. So please do this last one. You didn't pick this up, did you? This one right there. Don't do it. Good. We can either have 3 pi over 2 or negative pi over 2. Many of you have one, many of you have the other, and we're cool. You can even do -3 and pi over 2. That's fine. We all comfortable with this? If we went in the other direction, well, some of them are going to be more obvious than others. If I have an r of 10 and a theta of 2 pi, well, where's the theta of 2 pi? It's all the way around our circle, coterminal with 0. R of 10 means we're 10 away. Okay, I can see I've gone to the right 10. I've not gone up or down at all. Here is my XY point that I just figured out. The next one I would just figure out using the triangles, using scaling. The last two involve a little bit more thought. See if you can give me the XY point of r equals -4, theta equals -pi over 6. Please do these ones on the notes before we get into the homework. And then once we flip over to the next page, everybody's putting the homework away because it's completely. Last one's wrong. But I like the idea of the last. Oh, come on. Pi over 6. Pi over 6. Come on. Where does it look like? What triangle is created? You got this. Draw the triangle. You're in the wrong quadrant. It might mess you up.
I'm doing it.
I don't. I'm sorry. What's the XY coordinate here? Your signs are wrong. But I would make that triangle be a little bit more exaggerated in case you have like trouble figuring out that this is bigger than that. Also, you're going in the other direction. Yep. -4 could be going in the opposite direction. So your signs are wrong. Pay attention to the direction we're going. If anybody's making mistakes here, it is with the signs. You think you'll do it right? Good. Good question. Good question. We will get there. Not yet. I'll show you. We're going to get there, just not yet. All right. So here's where people are making mistakes on this one on the right. We should be going to the angle of pi over 6, -pi over 6, which is here. However, we should be going in the opposite direction to really an angle of like 5 pi over 6 or -7 pi over 6 because our radius is -4. Now the radius of -4 puts us over here, but you can consider that length to be 4. You're a length of 4 at 5 pi over 6. Now, what are the x lengths and the y lengths? What you can do always is use your representative unit triangle and then scale it. Your unit triangle at the pi over 6 has a -√3/2 and a +1/2. Multiply everything by 4. This becomes a +2. This becomes a -2√3. I'm going to the left. I'm going up. Got it? Great. The next one, a little trickier. The last one, the trickiest. If I'm traveling at an angle of pi over 4, a length of pi over 4. What do you get? Yep. It's just weird, but it's right. No. Well, look, I'm showing you. What we can do is take our units, 45, 45, 90 triangle, and multiply it, scale it by this new radius of pi over 4. What does that look like? It's not going to look pretty, but it's going to be right. You take your units, 45, 45, 90 triangle, scale it by pi over 4, giving us root 2 over 2 times pi over 4 in both directions, which is root 2 pi over 8, comma, root 2 pi over 8. And that, my friends, is correct. Cool. So a little bit more weird looking, and then we get to the last one. And guys, I want an exact answer for the last one. I want you to pretend like you had a calculator. And I want you to pretend that you could type in anything into your calculator and get a decimal answer. But your exact answer will be like in the form of what you would type into your calculator. Now, many of you are like, I have no idea. This is not a triangle that I'm familiar with. You're correct. You do not know the triangle that is created with an angle measurement of 2, whose radius is 5. But maybe don't think of it this way. Maybe instead just think of it like a triangle, where you have a hypotenuse of 5 and an angle measurement theta. And that theta is 2. You have an angle and you have an hypotenuse. Then you're trying to find an x and you're trying to find a y. What would you type into your calculator to find x and y? Go. Tell your neighbors. You got it? Very nice. You got it now? Yeah, very good. The tangent of 2 is y over x. That's cool. But that doesn't help you use the fact that you know the radius is 5. Really good. That's what it is, Paul. I love the attempt, Regner, but it's easier than that, guys. What's great? Yes, good job. What's great about trigonometry? If you have one angle, you have an angle in a right triangle, you have any of the side lengths, you can use trigonometry to find the other side length. Why? Because the sine of the angle equals the opposite over the hypotenuse. The cosine of the angle equals the adjacent over the hypotenuse. This, guys, is actually what is going to be more important moving forward on the last page of your notes. The fact that r cosine theta is an expression of what you guys have been doing with your triangles. You found your unit ratio in a unit triangle and you scaled it. You found the ratio for your y's and you scaled it. It was just like done with triangles intuitively, but really what you were doing was r cosine theta and r sine theta. Like solving for x and y. So my answer is 5 cosine 2 and 5 sine 2. And guess what? The cosine of 2 is going to be negative. So it puts me in the correct quadrant. I don't have to write that it's negative. I don't have to write that the x coordinate is going to be negative. Cosine of 2 takes care of it. Sine of 2 is going to be positive. Great. Figured that out. What? What? No. All right. Now, everybody put your homework away. I don't want to see any homework near the top of a pile. This is new stuff. I need you all to pay attention to your notes. Your homework is away. Your homework is away. Did you have a stack of papers that had Battleship on it over here? Oh, yeah. There's 2. There's not a stack. You missed it. We had fun. Did anybody see a stack of papers that had Battleship on it?
Oh, somewhere on my table over there. But like, I don't think
Oh, cool. Thanks. All right, I'm going to be passing these out shortly, but okay. Team. What we are about to dive into, all you have to be able to do is not that complicated, and you should not be that intimidated by it. But the reasoning why we are learning this actually is for a very advanced mathematical topic that if you take advanced math classes in college, you will get into. But it's the reason why they're telling you, you need to learn this now, so that when you see it later, it's not just like, I don't get it. Where do we start? Like, okay, I'm kind of familiar with it. All right. So it starts with solving x squared equals negative 1. What are the solutions to x squared equals negative 1? Tell your neighbors. Close. You said I. I know you're wrong. This brings us to a very, very important aspect of algebra that you learn from polynomials. If you have the polynomial x squared plus 1, and I ask you how many zeros are there for x squared plus 1, what is your answer and why? Please tell your neighbors. Focus, focus, pay attention. This is fun math stuff. How many zeros does x squared plus 1 have, and how do you know that? It's very simple. It's got 2 because it's x squared. So when you guys said I, you should have known, oh, that's not right. It's got to have 2 solutions. So this is the other idea, which is that complex solutions always show up as what? What was that thing we learned? Pairs. Very good, those of you who remember. Complex solutions always had a plus or minus. Always had to show up in pairs. Okay. Now, we are going to do something that just seems weird. Why do we do this? And eventually we'll see why on a different sheet of paper, not even on these notes. We are going to plot complex values like I and negative I on a complex plane. This is not an x-axis and a y-axis. You can think of it as an x-axis and a y-axis. Rather, this is a real axis and an imaginary axis. Okay? There's some equation out there, some quadratic equation, whose solutions are x equals 3 plus or minus 3i. Cool? There's some quadratic equation whose solutions are 3 plus or minus 3i. Well, I'm going to visualize said solution on this complex plane. Here's how we do it. We'll go to the right 3. We'll go up 3i. This would be 3 plus 3i. The real 3, this would be the I part, the imaginary part. So graph 3 minus 3i. Can you do that for me? Where's 3 minus 3i? Good. 3 minus 3i. It's very much just like graphing x's and y's, but we'll get into why we would do this. Sorry, that's 3 minus 3i. Eventually. We could graph just I. Where would I be? Not 3i. Where would I be? Where would I be? Graph I. Well, I think I would be no real and just up 1 I. That's where I is. Where would 2 minus I be? Graph 2 minus I on the complex plane. 2 minus I, no big deal, right? Great. You might have actually done this in previous math classes, not knowing why you would do this, what reason there are. Now I'm going to show you something else. The value of I, z equals I, can be expressed a different way using r sine theta and r cos theta, just like we kind of did for that last problem where theta was 2 and r was 5. We had 5 cosine 2 with 5 sine 2. I'm going to go back over to the z equals I right here. And I'm going to realize, oh, this is kind of on a radius of 1, and it's at an angle of pi over 2. Would you guys agree with me that this point, if it was like on a rectangular plane, would be a radius of 1 and an angle of pi over 2? Cool. I'm going to write an equivalent form of I using r cos theta and r sine theta, where r is 1 and theta is pi over 2. I'm going to say I is the same as 1 cosine pi over 2 plus 1 sine pi over 2 I. And many of you are probably like, why would we do this? This seems silly. Why would this seem silly? Tell your neighbors, why does this seem silly? Why, it's like, why does this seem silly? Why should you be asking yourself, what the heck are we doing that for? Has to deal with what the cosine of pi over 2 is. What's the cosine of pi over 2? Okay, so this is 0. What's the sine of pi over 2? 1. So really, this is 0 plus I. Oh yeah, of course, it's just I. Why the heck would we write it this other way? I'll show you eventually. Now let's go to another one. Who is making that noise? And is it one of you? Yo, is it somebody at this table? Because it's like, yo, it's probably a sophomore. I'm going to start with that. Because you guys are super immature. And if it's a junior, then you're better than that. And if it's a senior, just leave, okay? Go do something else. Oh my gosh. It's actually not from this table, and I'm shocked. I feel like it's from that table. Great. No, it's cool. You're really cool for doing that. I'm glad we're being really mature here. All right. We have 3 plus 3i. So I hope you're like happy and like, Ew, take a picture of that. Gosh. Kids. You kids are so stupid sometimes. All right. 3 plus 3i right here. Well, I know that this is at an angle of pi over 4. I know the radius would be 3 root 2. If this is 3 and this is 3i, I know the radius is 3 root 2. So 3 plus 3i, I know is a radius of 3 root 2, and I know is a theta of pi over 4. Like, what is going on? So we got r cosine theta plus r sine theta. It's a 3 and a 3. 45, 45, 90. So if it's not you, if it is you, then like, wow, you're really bold. But if it is just something in the air, I know, right? Okay. Murph knows who it is. Okay. Now you're probably thinking this makes no sense. I know the cosine of pi over 4 is root 2 over 2, which means this turns into just 3. And this just turns into 3i. Why am I writing it like this? You're just responsible for understanding that you can. I'm going to show you why. You don't have to understand why, but some of you are going to appreciate it shortly. Okay. How are you going to be tested on knowing this? Here's a question straight out of your test. I think it's almost the exact same as what you're going to have on your test. So like maybe you'll pay attention now. Great. We have 4 complex points. 3 plus 3i, 3 minus 3i, negative 3 plus 3i, and negative 3 minus 3i. Guess what? These points all represent solutions to some crazy equation. There's some sort of x to the 4th equation that has 4 solutions, all 4 of which are complex, that the solutions are x equals 3 plus or minus 3i and x equals negative 3 plus or minus 3i. Okay? And this is what all 4 of those solutions look like. Now, here's how you're tested on it. Okay. All 4 of these points can be listed off as 3 root 2 cosine of a theta times I, 3 root 2 sine of a theta. Now, obviously, if you've paid attention, which some of you have, you realize that if this is 3 and this is 3, this is 3 root 2. Oh, yeah, they're already telling me my r is 3 root 2. That's already given to us. Pombo, are you cool with 45, 45, 90 triangles, x, x, root 2x? We kind of talked about that at length. Great. So they're giving you r. All they're asking you is, yo, what is the angle? And then what is this angle in relation to that angle? And then what's that angle? And what's that angle? That's all they're asking you. This seems like a very complex question, but it's not. What are the angles? Is it pi over 4 plus multiples of pi over 4? Is it pi over 4 plus multiples of pi over 2? Is it pi over 4 plus multiples of pi? Is it pi over 2 plus multiples of pi over 4? Is it which one of these are the angles where your 4 points are located? Thanks, Miles. Go ahead and write down your answer, A, B, C, D, or E. And then I'm going to show you why, and it's actually fun. Careful. Pi over 4. 2 pi over 4. 3 pi. No, because you're doodling, bro. That's maybe why you don't understand. That's great. I love when kids are just like, Guys, I haven't been paying attention. I really don't understand this. Yeah, no kidding, you don't understand it. If this is 3 and this is 3, what's the angle? No. They're telling me they plotted these points. These points are plotted. I can see it. 3 and 3.
And then that's something. Unless I'm tripping here.
Oh, no.
Yeah.
Good. It's either A, B, or C because we can see that the angle is at pi over 4 to get to this point. This angle's 3 pi over 4. This is 5 pi over 4. And this is 7 pi over 4. We cool with that? So we're either A, B, or C. But a lot of people selected A. But you're thinking of pi over 4, 2 pi over 4, 3 pi over 4. If you add a multiple of pi over 4, you're wrong. Right. This is not correct because this would include 2 pi over 4. What you really need to do is add 90 degrees. Pi over 4 plus 2 pi over 4 gives us 3 pi over 4. Plus 2 pi over 4 is 5 pi over 4, et cetera, et cetera, et cetera. So what's the answer? Good. Now, why do we know this stuff? Because of the next thing you're about to learn. Please keep your homework away. I'm going to give you an extra sheet of paper. You are going to write down the notes like you're a grown-up student who doesn't get notes, and you're just going to write this down like you're in college and you're taking notes for a lecture because you're big kids who are in a college class. So please write down the next stuff that we're about to do, just a half a page of stuff on this thing. And don't you dare look at your homework.
I'm not sure.
I'm out. You guys have to get out a sheet of paper like grown adult students. Or who has paper that they can share? Here, use that.
Oh, yippee guys.
Flip it over.
Battleship.
No. All right. Here we go. Please copy down this equation. Please solve this equation. And let's see if any of you can get the answers. I'll let you know that most of you won't. Maybe 1 or 2 of you are paying attention and you'll be able to get this right. The ghost of AP Precalc. We're looking on the board. We're copying down that equation. How many of us are going to get the correct answers? Yeah, there's one. Go ahead, come on. What are the answers? You don't have to solve the equation. That's correct. You can just go ahead and give me the equation. Many of you are doing what I expect you to do, which is just be like, 1. A lot of you are putting like the 4th root of 1. And great, you're a 4th of the way there. How do I know that you're a 4th of the way there? Guys, it's an x to the 4th equation. There has to be 4 solutions. Okay, so obviously 1 is one of them. What are the other ones? Well, maybe it's easier to see the factored form, the difference of squares form. This is me solving this algebraically. I can factor. That's algebra. Factor. Now, can you adjust your answer? The answer is not just one. There are 4 answers. What are the answers? Thank you, Pombo. We get plus or minus 1 from this equation. We get plus or minus I, because we talked about this earlier, from that equation. Here are my 4 solutions. 1, -1, I, -I. Now I'd like you to actually graph those 4 on the complex plane. So remember, it's not x's and y's, it's a real part, an imaginary part. Cool? Here is x equals 1. Here is x equals -1. Here is x equals I. Here is x equals -I. These are the 4 roots, the 4th roots of 1. These are called roots of unity. Now, please discuss with your neighbors. Do you notice anything about the visualization of our 4 solutions to x to the 4th equals 1? Tell your neighbors, what do you notice? Do you notice anything? So many of you notice like the shape, are noticing the symmetry. Here's what I notice. We have a radius of 1 to get to all 4 of the points. We go 1 away from the origin to get to the 4 points. Cool? And I took my circle, which is a total of 2 pi radians, divided that into 4 parts, and I realized that all of these points are pi over 2 away from each other. Cool. I can utilize that the radius is 1 and that the angles are all pi over 2s away from each other to write my solutions. My solutions are r cosine theta plus r sine theta I, but theta is one of my pi over 2s, just like how we express those points in the 4 corners. We said they were pi over 4 plus pi over 2n. I just have my pi over 2n. Cool? Plug in pi over 2, boom. You got this point. Plug in pi, you got that point. Plug in 3 pi over 2, you got that point. Great, great, great. Still not seeing it. We're going to get there. Let's go to this equation. X cubed equals 1. Please solve this equation. If anybody gets the 3 answers that exist, hats off to you. Way to go. Your Algebra 2 teacher needs a phone call. For you, Diallo, I'll give you so much extra credit. So go get it, Diallo. You got it, bud. Here we go. Everybody else, you don't get extra credit. Diallo gets extra credit when he gets the answer. Murph, I'll give you extra credit if you get it right. Okay? Yeah, sure, sure. Yeah, I'll give you extra credit, Lazara. Anybody else want extra credit for getting this right? Okay, great. If you guys get it right, I'll give you extra credit. Okay, you're not done yet. What?
Oh, I know.
Yo, who's about to get extra credit? Well, who's your Algebra 2 teacher? Oh, all right. Anybody? Yeah, you got it? Yeah, you got it? Yeah, no, you don't. No.
I almost got it.
I cubed yellow is not 1. I squared is -1. Then times another I is like -I. Oh, man, Hool, you're on the right track. You're the only one of all of my students that remembered that. There's 3 solutions. If you get the 3 solutions, I will give you extra credit. You don't have them. No, you don't. What are you doing? From what? What's the quadratic formula from? All right, ready? Yo, actually, Diallo, you're closer than you think. Cool was the closest that I've ever seen. Sorry, Wolf. Guess what? This one you can actually algebraically solve. This is going to be the last one that we can algebraically solve. We can use the soaps. Everybody remember soap? You can use the socks or the docks, which don't make sense to me. I teach the soaps. A difference of cubes can be factored. This is x cubed, this is 1 cubed. You will have x and 1, you will have x squared, you will have 1x, you will have 1 squared. You keep the same sign. You don't have to know this, guys. This is just like, did you remember things from algebra 2? Same sign, opposite sign, always positive. Who was the only one who was able to have that factor? Nobody else, the entire class, all of my students do that factor. Now, many of you were correct in one of your solutions, x equals 1. Yeah. But we will be getting 2 solutions from this. X squared plus x plus 1 equals 0. How do you solve this quadratic equation? So what?
Isn't it like
I think you were right, just the way you said it, I couldn't understand.
negative b over 2?
The quadratic formula. You were going to try to factor, but you can't. That's where we failed. Is that we always have a backup for quadratics. Ready? You were on the right track. How did you know to do this? Yeah, you did. Okay. Ready? X equals the opposite of b over 2a. I like to keep it split up. Yo, if you consider yourself somebody who enjoys mathematics, like this will be something that's like interesting to you. This is one of those big things in mathematics where it's like, wait, this is related to this? Why are they connected? How are they connected? Because math works in mysterious ways. Bros, Lazara, maybe turn around and just watch the rest and just like, yeah, put your pencil down. Can you just watch the rest, bud? Appreciate it. Okay. X equals the opposite of b over 2a, plus or minus the square root of b squared minus 4ac. We don't have to show all the work. We can do this in our head. B squared is 1. Minus 4 times 1 times 1. It ends up just being 1 minus 4. That's negative 3. All over 2a. We cool with this? All right, great. Now, we get negative a half plus or minus the square root of negative 3. I'm going to write as an imaginary number. Root 3 over 2i. And here are my 3 solutions. X equals 1. Turns out negative 1/2 plus root 3 over 2i cubed is 1. You don't believe me? I could plug it into Wolfram. I'll do it later. If you take this in parentheses and cube it and distribute everything and do the math correctly, this cubed is 1. Cool? I promise. If you take negative 1/2 and subtract root 3 over 2i, if you take this in parentheses and cube it, do all the math, you get 1. It is a solution to x cubed equals 1. Now, let's graph these. on the complex plane that has real parts and imaginary parts. Where is our first solution 1? Please graph your first solution 1 on the complex plane. There is x equals 1. Where does negative 1/2 plus root 3 over 2i exist? Well, I'm going to go to the left 1/2, and I'm going to go up root 3 over 2i. I went left 1/2, I went up root 3 over 2i. I could go left 1/2, I could go down root 3 over 2i, and I get my third solution graph. What do we notice about these 3 points? Don't say they make a triangle. I like that answer. And triangles are important here, but not this triangle. We got that, Dove. And then you, Shaw. They're 2 pi over 3 away from each other. Anything else? With a radius of 1. Which means these 3 points are all also found on a unit circle in the complex plane. All 3 angles are 2 pi over 3 away from each other. It's almost like we took the entire circle and we split it, Archer. You don't have your phone on you, do you? Into 3 parts. We get 2 pi over 3, 4 pi over 3, 6 pi over 3. It's almost as like we could write the solutions as r cosine theta, where theta are multiples of 2 pi over 3, plus r sine theta, where theta are multiples of 2 pi over 3, times I. And again, you're probably like, well, why do I have to write it like this? Because I know what the cosine of 2 pi over 3 is. It's negative 1/2. I know what the sine of 2 pi over 3 is. It's negative root 3 over 2. Well, here's the question at hand, which is why we're doing this. Give me one solution to x to the 5th equals 1. There's 5 of them. I'm going to give you one. I want somebody here to give me another one. My solution to x to the 5th equals 1 is 1. That is one solution to the equation x to the 5th equals 1. Could you give me another solution where I could take the solution to the 5th power, and when I take that solution to the 5th power, I'm going to get 1. Yeah, Pablo, you and Lazar are like shaking your head, nodding your head. Yep, yep. Hey, buddy? Yeah, you're going to get it? I want a solution that x to the 5th equals 1. That's not 1. Anybody? Should I give somebody extra credit? You got one? What is it? Cosine comes first. Cosine comes first. Nice shot. Did you get that? 2 pi over 5. 2 pi over 5, 4 pi over 5, 6 pi over 5, 8 pi over 5, 10 pi over 5. Now, guys, let me just show you what we learned. Okay. Just going back to negative 1/2 plus the square root of 3 over 2 I cubed. I'm telling you that if I take negative half plus the square root of 3 over 2I and cube it, that I'm going to get 1. Now, thank you, Wolfram, for being capable of doing this. No, something happened. I need to put I in front of the squirt. Boom. Look, negative a half plus root 3 over 2I cubed. Doing all the math gives us 1. Now, what we said is that instead of writing it in this form, you could say that this is the cosine of my circle split into 3 parts plus I times the sine of my circle split into 3 parts. And you're going to get the same result, which is negative a half plus root 3 over 2I squared or cubed, and the result's 1. Now, here's the problem with this question, is that we got this answer algebraically. We factored this. I have no idea how to factor this. But by looking at the solutions to x to a power equals 1, looking at the roots of 1, we notice some similarities, Ford. All of my solutions ended up equal distance from each other. It's almost like I could take 2 pi and divide it into 5 parts. We'll have 1, we'll have 2 pi over 5, we'll have 4 pi over 5, we'll have 6 pi over 5, we'll have 8 pi over 5. We'll create kind of like a pentagon, sure. But I will be able to say that all of my solutions will be the following, just with my angles being 2 pi split into 5 parts and multiples of those. Brings us to it working. Watch. If I change this to 2 pi over 5, and I change this to 2 pi over 5, and I change this to 5. Now, here's the key to why we are doing this. This is the first instance where Barry, everybody else who just doesn't care anymore, just pay attention or keep your mouth shut for the people who are paying attention. This is the first instance that you don't know the cosine of the angle. You don't know what the cosine of 2 pi over 5 is. You don't know what the sine of 2 pi over 5 is. However, I know that this has to be a solution. I know it's got to follow the same path and the same process of the third roots of 1, the fourth roots of 1. If I take cosine of 2 pi over 5, I don't know what it is. Sine of 2 pi over 5, I don't know what it is. Times I to the 5th power, I get 1. Now look, this is actually the number of the cosine of 2 pi over 5. Yeah, good luck trying to find that by hand. This is actually the number of the sine of 2 pi over 5. Yeah, very, very complex. However, this is correct. And if you take this to the 5th power, you get 1. Which means, if I asked you to give me a solution other than plus or minus 1 or plus or minus I to x to the 123rd equals 1, what is it? And all of the multiples of 2 pi over 123 that exist there. Ready? Watch this. I plug in 123, 123, to the 123rd. I hope that Wolfram doesn't break. I hope that Wolfram doesn't break. Oh, bam, 1. There you go. All right, so if you end up in more complex mathematical classes, you actually get into that stuff more. Hope you enjoyed it.